Hello, welcome to Pragim Technologies. I am Venkat. This is part 3 of .NET Basics. In this session, we will learn how to strong name an assembly, that is, the process of signing an assembly with a private and public key pair. Now, in .NET, the assemblies can be broadly classified into two types, weak named assemblies and strong named assemblies. Okay, let me give an example. Now, if you look at this program, this is a very simple C# program. All this is doing is printing this message onto this console. Now, to print this message onto the console, we are using the console class. Now, where is this console class coming from? It is coming from the system namespace. And where is the system namespace present? It is present in the system assembly. And where is the system assembly? Okay, it's nothing but the .NET Framework assembly. When we install .NET on this machine, two very important components get installed. One is the .NET Framework class library, and the other one is the runtime environment, which is nothing but CLR. And within .NET Framework class library, we have several assemblies. So when I install .NET, where does these assemblies get installed? They get installed to a special location called GAC, Global Assembly Cache. So within this Global Assembly Cache, we have all the .NET Framework assemblies. However, that is slightly different for .NET Framework 4.0 assemblies, which we'll be talking about in a great detail later. Okay, now the path for GAC is basically C drive, operating system directory, and then assembly folder. So on my computer, it's C:\/ the operating system directory, and my machine is Windows. On some of the machines it could be WinNT, or some other name. So C:\/ operating system directory and \assembly. So this folder is called GAC. It's given a special name because all the .NET Framework assemblies reside in here. So if you look at the assemblies here within this GAC, okay, all these assemblies are strongly named. Now, how will we distinguish between a strong named assembly and a weak named assembly? We'll come to that in a bit, but trust me, these are strong named assemblies. Now, if you look at an assembly, any assembly within .NET, the assembly name basically consists of 4 parts. What are they? The 4 parts are, if you look at the presentation, the simple textual name, which is nothing but this name. For example, if you take the system assembly, so this is the name of the system assembly. So the simple textual name is just one part of the full assembly name. And then the version number. Okay, what's the version number? Is it 1.0.0.0 or 2.5? What is the version number? And if you look at the version number itself, it can be again divided into 4 parts. We'll talk about that in a bit. And then the third part is the culture information. Okay, most of the assemblies in general are language neutral. We'll be talking about culture also in a bit. And then finally, public key token. Okay, not all assemblies will have public key token. Only if it is a strong named assembly will it have. So that's the way to identify whether if an assembly is a strong named assembly or a weak named assembly. If an assembly has this public key token, then it is a strong named assembly. Alright, let's talk piece by piece here. All the 4 different parts that form the name of this assembly. So this is a simple textual name. Basically, it gets the name of your project. Okay, so that's your simple textual name. And then we have the version number. If you look at the version number, the version number can again be divided into 4 parts. The version number can be again divided into 4 parts. If you look at this, we have 1.0.0.0. Okay, so basically 1.0 version of this assembly. Okay, and if you look at these 4 parts, the first part is called the major version, the second part minor, build number, and revision number. Now, typically any software will undergo a change over a period of time, and then when we introduce new features or fix bugs, depending on the significance of the change, we either change the major number or the minor version number. If the changes that we are making to our application are huge, then probably we'll change the major version number. Otherwise, we usually, if the changes are small, then probably we just change the minor version number. That's why you might see applications, application version 1.0 or version 1.5 or 2.5, etc. Okay, but most of the time the build number and revision number are defaulted. Okay, let's look at how to change the version number. For example, if you look at this project, it has got a very simple project, and when we compile this we get an assembly. And if we go into the bin folder of this project, you should see that assembly. And if I right click on that, and if I go to the properties, or in the previous session we have seen how to use the ILDASM tool, okay, to change the assembly version, to check the assembly details. So if you go into the details here, you should see that the version of this assembly is 1.0.0. This is actually a file version. If you want to check the version of the assembly, it's better to use the ILDASM tool. And it's very simple to use the ILDASM tool, which we have seen in the last session. And to change the version number of this assembly, all you got to do is every project within .NET has got this assemblyinfo.cs file. So you expand the properties folder, get into assemblyinfo.cs file, and if you look at, there is an attribute called assembly version in this file, and this is the major version, this is the minor version. So for example, let's say mine is a 2.0 version. I just put number 0 there, build my application. What happens, this information will be returned into the manifest of this assembly. Okay, and we have seen what is a manifest in the previous session. Okay, and to check if it has been written properly, we can use the ILDASM tool, and we discussed how to use ILDASM tool in the previous session. So basically this is how you change the version number of an assembly using this assembly version attribute. Now usually we change the major version or the minor version depending on the significance of the change, but on the other hand, usually the build and revision numbers, we can default that to asterisk like that, and when you compile your application, the compiler basically assigns the build and revision numbers. Okay, that's how we change the version number. And the next part of the assembly name consists of the culture information. Now most of the time, the assemblies are language neutral. Okay, especially when we are globalizing our applications, that's when we provide culture specific information. Okay, now to change the culture of an assembly, so if you look at the GAC, which is nothing but this particular path, C Windows assembly. In the GAC you see this culture. Most of these assemblies are actually language neutral, but there could be some assemblies with the language, here the language is English, so the culture is English here. Similarly, for other assemblies you might have different cultures as well. Alright, so when you specify a culture, then that assembly becomes a satellite assembly. Now we will talk about satellite assemblies in a later session, so let's not worry about them right now. But for most of the assemblies, the culture information will not be there. By default, if you want to specify the culture information, you use the assembly culture attribute. So here we have the assembly culture attribute. We use that. For example, if you specify anything apart from an empty string here, then this assembly is like a satellite assembly which contains resources specific to that culture. But most of the times the assemblies are language neutral, meaning main assemblies, which contains the main application code plus the resources for basically neutral culture. Okay, so assembly culture is usually empty. Alright, and the final important part of the assembly name is the public key token. So if you look at the GAC, there is a public key token here that is generated. So how did we get this public key token? What's actually happening here? Now in order to get the public key token, you need to sign your assembly with a private and a public key pair. Okay, so obviously if I have to sign the assembly with a private and public key pair, I need the key file which contains those keys. So how do I get those keys? Now it turns out within .NET Framework we have a tool called strong naming tool. We can use this particular tool to actually generate the key pair. And again, to use that tool, we go to the Visual Studio command prompt because it's a command line tool. Okay, so let's go to Start, All Programs, Microsoft Visual Studio 2010, Visual Studio Tools, and Visual Studio Command Prompt 2010. Right click, Run as Administrator, and here we use that tool sn.exe, strongname.exe. So sn.exe, and use the switch -k to indicate that you want to generate a key pair, and then give the name, specify where you want this key file to be generated. For example, I want this file to be generated maybe my strong keys. And key files basically has an extension of .snk, so specify the extension. Now when I press enter, it's going to write the private and public key pair to that location. So if I navigate to C drive now, I should see that key pair. So somewhere here I should see my strong keys. So if I sort this by date modified, so my strong keys.snk, okay, that's present in the C drive. So let's copy that, and then within assembly info.cs file we have an attribute called assembly key file attribute, which we use to strongly name this assembly. So how do we specify that? So I want to sign this assembly using that attribute, and to the constructor of this assembly key file we pass in the path of our key file, which is present in C:\\, and then specify that. Now if I build this solution or this project, what's gonna happen, okay, by the way, we have to escape that with another \. So let's rebuild again. So when we rebuild this, rebuild all succeeded, what happens is this assembly is now signed with a private and public key pair. This file basically contains these two keys which will digitally sign, which will sign this assembly with this private and public key pair. Now this assembly will have all the 4 parts. Now how to look at those details, we'll talk about that in our next session when we actually deploy this assembly into the GAC. Keep in mind, only strong named assemblies can be deployed into GAC. Now we spoke about that in .NET we have two types of assemblies, weak named and strong named assemblies. Only strong named assemblies can be deployed into GAC, can be copied into GAC. If you try to copy a weak named assembly, you will get an error. It's not possible. And then strong named assemblies are guaranteed to be unique, so they solve a major problem called DLL hell. Okay, so but weak named assemblies are not guaranteed to be unique, and there is a chance for DLL hell problem. Okay, so we will talk about what is DLL hell, how to solve it, and what is GAC in a greater detail in next session, and how and when to install an assembly into GAC. We'll talk about all these details in a very great detail in the next session. In this session, what we need to understand is that an assembly name basically consists of 4 parts: simple textual name, version number, culture information, and public key token. Okay, an assembly is said to be a strongly named assembly if it has got the simple, if you look at the next slide, a strong named assembly should have all of the following. It should have that simple textual name, the version number. By default, most of the assemblies have them. In fact, all the assemblies have them. Okay, the difference between weak named assemblies and strong named assemblies is that weak named assemblies are not signed with a private and public key pair, and hence they don't have a public key token, whereas a strong named assembly is signed with that private and public key pair. And strong named assemblies are guaranteed to be unique. So if the assembly is not signed with a public private key pair, the assembly is weak named and not guaranteed to be unique and may cause DLL hell, but whereas that's not the case with strong named assemblies. And as I told you, in the next session we'll actually talk about what is GAC, how and when to install an assembly into GAC, and the problem of DLL hell and the solution to that. On this slide you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.